Hi, my name is Chris Luckey. I teach Project Lead the Way Engineering at Parkview Arts and Science Magnet High School. My Strive internship this summer was with Nabholz Construction Incorporated. This is a very large and highly diverse construction company that's involved in every part of the industry. I was placed at the Arkansas Children's Hospital new South Wing site, where they are connecting the pre-existing hospital to a new facility that includes state-of-the-art sports medicine facility as well as high-tech labs. I spent the majority of my time here at the Master Facility Plan Office. This is where the main meeting place for project managers, subcontractors, architects, engineers, and foremen that work at this site. I learned that project managers are problem solvers. There are numerous design changes that occur during the construction process, and these are the guys that are in charge of managing those issues. My job at Nabholz was to monitor the progress of the 10th Street Sky Bridge and report the progress back to the project managers. So what I gained from being a Nabholz intern, one thing was I was able to see something new every day. I had a great time learning about all the different aspects of a large construction project, and I made sure to take copious notes on the STEM skills I observed and how I could use those in my classes. With so many types of jobs, I was able to observe a wide range of soft and practical skills. And I was really overwhelmed with all of the information that I was getting from the people that worked there. I was inspired by the project management and problem-solving aspect of the business. Specifically how specialized tradespeople and professionals must work together to contribute to the best working solution to any given problem. This experience fit well with my computer-aided manufacturing course, where students learn to use CAD and CAM software to create things with real manufacturing equipment. So my Strive lesson was entitled Solving the Storage Problem, where the main goals were to teach students how to use the engineering design process to solve a problem and increase their computer-aided design skills. So I started this lesson off with a hook where I described the problem that I'm having with the lack of floor space in my class. I designed a mobile storage rack that can hold the bins in which my students store projects in between classes. The bins are stackable, but only if the contents are not too tall. Students were tasked with designing a bracket to hang these bins on horizontal supports, so that there would be some space in between each bin for bigger projects. In teams, students followed the engineering design process to solve this problem, starting with defining the problem. Here you see some students creating a design brief in their engineering notebooks. We then generated concepts or brainstormed possible solutions. Next, teams used a decision matrix to pick a solution to develop. Students used Onshape to create CAD models and technical drawings. It's an essential skill in construction and manufacturing industries. Students practiced the critical skills of collaboration and digital documentation by creating and naming folders within a single shared CAD document. I was able to reinforce the importance of these skills using examples from my experience at Nabholz. Students were then introduced to CAM software and converted their CAD models into G-code. Here you see the CAM software we use is Ultimaker Cura. Students then loaded the G-code generated by the CAM software into the 3D printers to print their prototypes. Students tested each iteration of their bracket to ensure that they met the criteria. One team struggled to get their prototype to successfully attach and went through several redesigns. Another team was almost successful the first time, so I instructed them to try and make their prototype more cost efficient. I wanted to stress that iteration is the key to designing a working solution in manufacturing. And each team was able to develop a working solution. And here you see their final designs, as well as the finished product with the mobile storage rack. Students are now working on their portfolio presentation, which will serve as the main summative assessment for this project. So my two main goals were to increase their CAD skills. So I did a CAD skills pre-assessment, which they scored about a 76% average on that assessment. After the lesson, that was increased about 20% to 96%. I also did a pre-assessment for their understanding of the design process, and that pre-assessment had an average of 74%, and the post-assessment had an increase of about 16% to 90%. So I did see some increase on those things that I wanted to focus on. So reflecting on this, there were some pros and cons to this lesson. One was the increased ownership and engagement with this authentic and open-ended project. They really were kind of invested in making a solution because it's going to be used in the classroom for years to come. There was an increase in peer-to-peer communication and questioning. And also, this can be altered to focus on a different problem and is adjustable for other teachers. And that's also kind of related to one of the cons, is that it was very specific to my classroom, so it will take a little bit of work to adjust this type of lesson to another teacher's classroom. Also, the open-ended format can be difficult to manage, especially when one group gets a little bit ahead of another. You have to be able to deal with that. And you also have to have access to CAD, CAM software, and the 3D printing equipment. I want to thank you for listening to my presentation, and also thank UALR and Strive, as well as Nabholz, for this wonderful experience. Thank you very much.